Well, good day. I'm glad to welcome you back to another StatPREP webinar, this one for September. I'm Danny Kaplan, and I'm really pleased to be able to introduce our primary speakers for today, Kate Kozak, who's a member of the StatPREP leadership team, and Jennifer Ward, who's remarkably active professor in Washington State for teaching statistics. And they're going to be talking to you today about the activities that have been designed for the new little apps and showing you what example activities look like so that you can make use of them in your courses. Next slide. So the MAA, which is sponsoring the project, records these webinars. So just to make sure you know, the webinar is being recorded. The MAA retains the right to show it again and such, just what you would expect. If you don't want your face to appear on the screen, then keep your video feed off. But welcome. Next slide. Okay, so please ask questions as you go. You can unmute yourself. We're pleased to have spoken questions, or you can type your question in the chat window. I'll be monitoring the chat window, and so I may turn your chat questions into audio. And at the very end of the webinar, to help us in evaluating the program and in communicating with the National Science Foundation, which is funding the program, there's going to be a survey, and we'd appreciate you're participating in that survey. Next. Okay, so there's the title, Activities for the New Little Apps. And I want to tell you how to get to the new, go on to the next slide. How to get to the little apps. So first, there's always statprep.org. That's the easiest address to remember. And the little apps are contained in a menu item there. The little apps have their own site, which is linked to by statprep.org. And the name is statprep.github.io/little-app-site. And then you can navigate to the 10 or 12 activities that we've already got up, or to the little apps themselves. So everything is linked together. So those are good places to go to be able to make use of the little apps. Next slide. Okay, so I want to tell you a little bit about the little apps before we get started with the heart of the webinar. So there's a kind of philosophy. I designed the little apps, and then I've gotten a lot of feedback from instructors like you who had great suggestions for how to improve them, thus the new little apps. But the central philosophy of them is to work with real data. So data is always at the core of every little app. And working with real data doesn't mean just putting up some data set and working with that. It means being able to make choices about data. And for the instructors, that might mean choosing a particular data set for a particular context. I don't know how many there are, but there are roughly 200, including those from many statistics textbooks, as well as ones that we've added in. And each of those data sets, well, some are simple, but some of them have many variables available, which allows you to explore relationships or to pose a problem to students, like find two variables which show this kind of relationship or that. Every app is centered on a display of data. Every app lets you easily generate new samples so you can explore sampling variation, resampling so you can show what that's about, and shuffling for permutation tests. And every app has a virtually identical appearance and interface. They're different in that each app implements a particular statistical method, and working with the app lets the student observe how that method behaves and how it corresponds to the visual patterns that they can see in the graphs. And all the variables are available in every app. So even if you're doing a t-test and you need a categorical explanatory variable, the quantitative variables will be converted into that for you. Next slide, please. So the activities are lessons that instructors have written for the little apps. So they are activities that you would use with a little app. Every activity, each activity uses one little app, but the little apps can be used in several activities. And what the activity does typically is to identify for the instructor specific data sets and variables that illustrate a statistical lesson. And this is mostly just to save you time to let us share the work in locating relevant real data. But of course, every instructor and your students can browse through all the data sets and variables to find ones that are particularly interesting to you or that show the pattern that you want to display. And an activity provides both instructions for how to work through the little app and question prompts for students. So you could think of many of them as a kind of, could be done as a homework activity or as an in-class activity. Next slide. So we have 3 examples for you today. As I say, under the activities menu at the Little App site, there's a dozen or so. But we've got 3 today, and they're going to be presented by Kate Kozak and Jennifer Ward. Who's going to be starting first?
I am. This is Kate.
Excellent.
So I'm going to talk about using the common and rare little app activity. And so I'm going to go into this activity. So I'm going to click on this. Danny, if you could put that in the chat, that way if they want to go there, they can. So every activity has a similar kind of setup. They start off with the title and then what it's doing and what the activity is about. So this activity is to use distributions to explain what values are common and what are rare. So it's using the normal distribution, looking at common and rare, kind of the empirical rule is embedded in this. I'm going to tell you who actually authored it, so you know kind of who to give credit to. Every little app can be done, every activity, I should say, can be done through the website. So you could just give them this web address, or you can also download a Word document or a PDF document to give your students. I will let you know what I'm doing in my classes this semester because I'm virtual. I'm actually a synchronous class this semester. I'm actually downloading the Word document, converting it to a Google Doc, and then I give each one of my groups access to the Google Doc, to a different Google Doc, and then each group goes into that Google Doc and works on the activity together. And I can then go look at what they're doing while they're in their group works and activities. And I'm using Zoom and we do breakout rooms. And so it's been actually working really nice because then I can see what they're answering and what their answers are doing, kind of like I do in my class where I'm walking around the classroom and I've given them a Word document that I printed out. But here I'm going through their chat rooms. So also every little app starts off with a little orientation where your students can learn a little bit more about what is being discussed and decided in this activity. Again, this one is going to be looking at common and rare and what a standard deviation does and tells them. So we've got these different ideas in here. So this gives you the idea of that, talks about what a z-score is, and then it actually goes to the activity. So in the activity, I'll tell them to open up a very specific little app. I will go ahead and do that. And I realized I just made a mistake when I did that. So I'm going to go back. And the reason I did a mistake is that when you click on it, it opens it in the window you're in. So if you want to open it in a different window, you would need to do command click or control click or whatever computer you happen to be on. And that would open it into a different window. And then we can go into that little app. So this is what the little app looks like that goes with that activity. This is the little app that talks about points and density. As Danny mentioned, these little apps are used in other places, also other activities. You also don't need to have an activity to use them. They can just be used directly as they are. And then the activity will actually walk the students through and suggest to them, you want to use this source package, you want to use this data set, you want to use this response variable. And what allows the students to do then is go in to do those things. So we're going to pick height, I believe was what it was. And so we got to go find height in our list. And as Danny mentioned, there's lots of variables in these data sets. So this data set looks like it has 30 or 40. We're going to get height. And then going back to the source pack, to the activity, it then will tell them what to do. And it gives them some more ideas of what's happening with this. Oops, sorry, I went to the wrong one. Okay, so the it's going to show them kind of what's happening. It talks about a distribution. This is a density plot. It's a little different than a histogram in that it smooths it off the histogram. I like density plots a little bit better. And it gives them kind of an idea of what's happening. You can also make the graphs bigger so you can see a little bit more of what's happening. And then you can talk about this one actually doesn't look very normal. It actually looks a little bit off, but we can still talk about common and rare with this. And it has them walk through and play around with this, put in what they think is, they get a guess what they think a common or what an incredibly tall person would be, an unusually tall person. And then you can move this bar to what you think an incredibly tall person's height would be. So the scale's down here, so 175. The hardest part is your students will have to convert to centimeters. Not a big deal. And then you can move this bar by just clicking on it and then dragging to where you want to move it. And then you can see what percent you have. And you can do that with the other bars, move them where you need to if you want to move this bar. And that way the students can see, is their guess right? When they said what they thought was a tall person and a not so tall person, what did they think those heights meant? And were they actually considered rare? And then the activity has them walk through exactly what is rare. And when I do this, I just let my students walk through the activity. And I go in there and I kind of linger over my students in their chat room or in class. I linger over the groups and see what they're doing. And then I can correct things if I hear a mistake that I don't hear, or I can answer their questions, or I can just listen to what they have to say and see. It's amazing sometimes what they come up with. And they go through this and they answer all these different questions. And what I like about my Google Doc is I actually made space for them to put their answers to things so they know. That's one of the biggest things I see is students are like, well, what am I supposed to answer here? And so giving them space to say, here's where you want to answer and this is what you want to tell them. It gives them kind of a clue that they want to answer this. So usually my Google Doc, I have more spaces here, put those in. And then it even has them change to a different variable, different explanatory variable, so they can play around a little bit more with those explanatory variables and see if there's different information and if they get different percentages based on that. And so it gives them a really good understanding of that. This is an activity that would just take a class period, a 50-minute class period, or an hour and 15-minute class period. You could easily get through this activity. And I like it because it really gives a good introduction to a normal distribution. If we were to pick the other one, and I'm in the graph one, if I go back to data, I can actually pick a different data set. So I believe the other one they were using in this data set was blood pressure. Actually, I think it was systolic. So the hardest part is finding these. Some of the names are not great, so you might not know what they stand for. So we can always click on this little button here, which is called the code book. If you linger over the icon, you'll see it says code book. And then you can click on that and then you can see what other different variables mean. And I make sure my students understand how to do this also, so they can say, oh, that's what this variable is standing for. And then this one is got a fairly nice normal distribution shape. And then they can see how the percentages change on this one also. Also, by the way, if you hold your mouse over top of a bar, or actually over top of any spot, it'll tell you what the z-score is for that point. So if I hold it over the center, it should give me 0, which it does. If I hold it over this first bar over here, it gives me -1. So this is -1 standard deviation, -2 standard deviations. So it's nice because you can just hover over these and it'll tell you what that z-score is. And again, you can do it at any point. You can find a z-score for any point you want. Okay. All right, so that's this little app and this little activity. Jennifer, did you want to go on to the next one?
Yeah, I'm going to use this
Jennifer, I didn't hear you very well there. Not as well as we were before.
Is that better?
That's better.
All right, so I am going to share my screen. Actually, I'm going to put in the link. I'm going to give you a couple of links, actually. So there is a link to an activity. So here is the link to an activity that I created, and it's so new that it is only in a Google Doc right now. So it's not even up on the web page. And this just goes to show you that if you have an activity or something you've created, you're welcome to share it back with us, and then we can share it out with other people too. So it's not just us creating content, we would love to have content made from you guys as well. So there is the activity for the little app. And then the app that I'll be using, let's grab that link. Here we go. And now to share my screen. Kate, I think you have to stop.
Yes, I do. Stop sharing. There you go. Go ahead and share your screen.
Now it's fine. I think here's my screen. All right, so you guys should be seeing just the little app, and then here's the activity behind it. So I like to use this little app, Center and Spread, at the beginning of the term, because I want to try to infuse this app throughout the rest of the term. So we kind of start with a low stakes activity where we can see data really easily, generate data, randomize data, and then as the students get more and more familiar with it, later when we get to a little bit more complex topics, they're not trying to learn an app plus the topic, they've already played around with the app. So I have started in my online classes, which I've taught online for a really long time now, and they've all been asynchronous. So I have started to make videos of myself using the apps, and then I give that to the students right away so they can see me clicking the buttons. Because if I were in a face-to-face class, I would have the computer open and I would tell them, you click here, you click there, and then the next step would be them to use the app alone. So I really like this video because they can see what's happening, not be quite as scared of something and not be afraid to click on something they don't know what it is, and I can describe it. So at the top of my activity, I did give my link to a little 5-minute video tour of this app. And I did kind of make the video a little bit general because I click on lots of different things, not just specifically to how I'd work with this activity. So you're welcome to check out that video, be inspired to make your own videos, and then share it with students. And I try to keep them short so that I just tell them what to click instead of what to learn and what to click, if that makes sense. So with the Center and Spread activity, I want students to look at what happens to variables as the sample size changes, as well as when we randomize the sample. So take a new sample. And the goal is for students to compare what happened with this sample, what happened with that sample. Are they the same? Are they different? You could implement this into discussion groups really easily because you could have one student take a sample, report to the group, another student take a sample, report to the group, and they can discuss their findings. So you can talk about variability as well as what the center is of your data. So in our source packages, I'm going to choose the Little Apps dataset first. We have a whole lot of packages. You could also upload your own data if you have data that you've gathered from your classes, which is what I often do. So one of the source packages, Little Apps, has the dataset NHANES2. And from that dataset, there are a whole lot of variables, as Kate was showing you. And if you want to find out about the variables, you can click on the little Dalek, and then it'll tell you the code book. So if you need to find categorical or numerical data, you can use the code book to kind of help you out. So I'm going to choose the response variable number of pregnancies. and automatically the graph will change. And then I am going to use the explanatory variable of income. So my explanatory variable is actually quantitative, and what our little apps will do is it will split up that numerical variable into whatever values are below the median, so median or less, or greater than the median, which is kind of nice for our students because they might be used to seeing categories that are very discrete and kind of the wordy categories that this is this bar, this is that bar. And they're not used to having to create their own divider for that variable. And so here they can see that it can be done. And we've used the median, but you could easily use a quartile to divide up the data, not in this app, but like on your own if you have them do some work. So I have, I've graphed now the number of pregnancies that the people have had and then their income. And so you could ask the students, well, what do you notice about the points? So first the app says, well, what does a little point mean? So we want to have students understand what they're reading, not just understand the axes, but what does this little point mean? And if I have a whole lot of points, why, or rather, if it's really black, what does that mean? So why am I seeing a kind of a bar over here? Oh, let's make the graph a little bigger. Oh, actually, it's not really a bar, it's a whole lot of points that are kind of stacked together. So I have students in the introduction understand what the points are and why there's actually some horizontal spread to the data points. So instead of stacking all the points, like you might see a histogram make a taller bar, we've spread them out. And I think it's randomly. Danny might be able to speak to that a little bit more. Okay, I see a nod from Kate, that the points are randomly spread out. So you can kind of tip your head and imagine what a histogram might look like or a dot plot. So I want to see more than just the points on this graph. I'd like to see maybe the mean or the median. So if I go to the pancake menu, I can have parameters added to my graph. So if I click the box for show mean, it's now, you can see in the background, the mean is now shown for each of those categories. Or for the median, now this is a blue line. You do have to tell your students which is which if you turn them on both at once. You can show a standard deviation, which makes the graph a little bit busier, but you can start to look at kind of the common and rare, like Kate was talking about. So I'm going to show the median for my graph, and then you can also have confidence intervals, and then click on go back to the app. So now I can look at these two samples, or one sample of size 50 for the two categories, and then I can start comparing. Is there really a difference in the number of pregnancies based on, what was my variable? It was income down here at the bottom. You can also show an auxiliary graph. So if I click on that, what I like about this is that it has now combined all of the data into one big group. So instead of differentiating by above and below the median income, now we say there's no explanatory variable and you really just graph the data set. So now you can say, well, is there a difference between the entire group and then different subgroups? So
Jennifer, the auxiliary graph is showing up on the right and the original one got squashed down a little bit to the left.
Oh, interesting.
No, that's what it should be. I just wanted to point that out.
I was thinking bad squash because I've had some glitches in this. Yeah, so on the right, we have the no explanatory variable, and then the other graphs stayed on the left.
Thanks.
Yeah, thanks for pointing that out. All right, so let's go back to the data tab here. And I would like to take a different sample. So there's the little dice button, and I can click on it and it takes a new sample. In the bottom part of the window, you'll see the sample that was taken. So if you want to, you can copy and paste that data out to Excel and have students make graphs on their own. Let's say they want to make a histogram of this. Or you can use the app as a way to have a data set graph all the data, and then you can copy that, paste it into Excel or whatever program you're using, and then you can have data to work in your class with. So I will show you another couple of variables. The NHANES data set is pretty classic, and there's so many variables to work with. I'm going to change, let's see, I'm going to go with a variable, let's see, response variable of height, and then the explanatory variable of sex.
So Jennifer, before you go on, I want to mention a lot of people ask what is NHANES. So if you go to the code book, you can find exactly what it stands for. It's the National Health and Nutrition
Evaluation
Survey. I always get the last word wrong. So this is actually collected nationally data every year. So this is where this is. I can't remember what year this is. Danny, do you know what year this data is from?
I think this is 2014.
Okay.
Yeah,
So
so
just always ask.
yeah, thanks for bringing that that part up. And I'm not sure if it really shows all the data. If I click on the n equals 50, I can change the sample size. 50 was just default, but I can also click on all, and then you can see what happens. So there we go. There's almost 10,000 data points just in this data set that we have. So I'm going to go back and I'm going to click on n equals 100. So I'll take a sample of 100, and there's a box down here, stratify sampling by expand variables. And what that will do is it bumps my sample size up, and it takes 100 from each group. So now you have equal sample sizes. If you want to make some comparisons, you can now say, well, how did the centers compare for my two groups? How close are they? Are they pretty close, not very close? You can have students work through like getting a feel for what close means. Then you can also look at the spread of the data points. So is the variation among the males about the same as the variation among females? We can resample. So let's take a different sample of 100. And I like this because you can quickly see what happens to the medians as you take different samples. And you might even ask, is it possible to get the same median? How long would it take you to get to the same median? What if you changed the sample size? Could you find the same median? And you might sort of take this into almost like a two-sample t-test sort of application, because you can then compare two means, I'm graphing medians, and yeah, compare those two groups. Another feature of the little apps is the freeze button. So if I click on the little snowflake, it's going to freeze the graph as it is. And then when I go to the compare tab, I can take new samples, and on the right, you'll see the frozen graph. And then on the left, you'll see the resampled graph. So you can also, I think you can even change your sample sizes. There we go. And then resample, and then see what is changing, what is not changing between the medians when you have larger and smaller samples. So I like these apps because you can do something so quickly with just a couple button clicks, and your calculations are just done for you there in the app. There are some stats up here in another tab. It tells you the standard deviations of residuals and means and R-squared. So Danny, maybe another feature we could add are the basic statistics, just like the median and average.
Good idea.
Yeah, almost like yeah, the like one var statistics that you might see. Yeah, another data set that is pretty classic that, well, I guess it's classic because I learned about it a while ago, and it is from the Lock 5 book. And some of the data sets come from books that are not open source, so you might have to have the book to understand the data set fully if there's not quite enough information in the code book. But in the Lock 5 book, there's an example where we look at split bill And the data is the payment, so how much a meal cost based on the payment method. Let's take away that. Oopsie. There we go. So the data is telling us that there was I learned this from the code book, that we looked at number of people going out to a restaurant and they said, okay, you guys are going to split the bill. What's the total cost of the meal? And then another group was saying, go out to the restaurant, but you guys are going to pay individually, and then look at the costs. And so you can kind of see what happens depending on people's mentality of, well, everyone else is going to pay for me, so I might as well have, spend more money at the restaurant versus, oh, I have to pay for that myself. And you can see resampled from this, it's a relatively small data set. You can see the cost of the meal. I'll go to the code book so I'm not lying to you. Payment method, individual or split, number of items ordered, cost of items ordered, and this was in Israeli new shekels, actually. So this is an example from the Lock 5 book, so there isn't quite as much story behind it, but it just goes to show you that you can find something that might be interesting and then go seek out the original data set. So yeah, that is a couple of variables, couple of data sets that you can explore with this app, comparing the medians and then looking at the variation within each of the groups. The app or the activity that I created is brand new. It's had ideas that I've had running around in my head, but it is on paper there. You're welcome to take it, modify it, make it your own. If you find something really awesome, share back with us, because we'd like to share with all the other StatPREP people that have gone through the program, just like me a couple years ago. And we can use these in our classes to bring in real data into statistics. So Kate, I'll let you have it back and you can talk about your next app.
Okay. I did want to mention that the little app activities that have been written were written by our hub leaders for the different hubs we have around the country. And that's where those have come from. I need to find the right place to share. I always love when I don't have the right place to share. I think that's the right one. Yes, it is. Okay. So I'm now sharing. I'm going to go back. I've gotten disconnected here. So let me get back to here. There we go. Okay. All right. So so these were created by, and they are all, like we said, they're Word documents. So you can also, if you go, I don't like this part of it, or I want to change this, or this was not working great for my class, you can modify all of them, just as long as you give attribution to the people, to StatPREP and the people who wrote it. That's fine, because you can edit these and change them as you want to. So the last activity we're going to talk about today is introducing linear regression. And there's, again, several activities that do linear regression. This one here is just really an introduction to linear regression. And again, it talks about that this is what the purpose of it is, who the author is. And Helen is actually our hub leader from up in Seattle. And so this actually gives the, and I forgot to mention, Thomas was the hub leader of the last one, and he's from Texas, Fort Worth. And so again, they're all in Word or PDF versions. And I usually either give well, like I said, this semester, I'm giving my students a Google Doc that I created. But I've also just given my students a paper version in class that they work on. I might use the Google Docs even when I'm back in face-to-face classes, which I don't know when that'll be, but we'll see. So we're gonna go ahead and look at, this one is actually a different one. This little activity, this activity actually has you as the instructor introducing the concepts using the little app, going through this. So again, I'm gonna go ahead and open up this little activity. And here's the little app. And this is one on regression modeling. this first page, we've kind of been going over it real fast. It just gives you an explanation of what all these different pieces are that we've been mentioning. So if you forget what one of these buttons are, this very first thing that comes up kind of tells you what all these different things do. And then you can just dismiss this. If you want it back, you can always get it back by just hitting the I, and the I will bring this back. So it's not that you have to memorize all this. You can bring it back up. And it's a good way for your students to see how to do it. And so this is a discussion you would use in your class, and you'd go through and say, okay, I want us to go into this little app. I'm going to have us work with the NHANES data again, and which we have at the moment. And then I'm going to have us pick a certain response variable. And we're going to pick BMI. And what's nice about this is it actually gives you an idea in the activity of what is BMI. So there's actually a link over here to what is actually BMI by the CDC. And then also, how do you calculate it? So if your students want to actually calculate their BMI, they can. So it gives them a way to actually bring these variables to internally to understand what they mean. And that's a very nice feature of this little app. And then, or this activity, I should say. And then they want you to actually look at age. So, whoops, wrong place. And so I'm going to come down here to age. And I can see that, and the reason, by the way, the other graph was that way is that they were a categorical variable. This is where we have two quantitative variables going on. And you can see that there's a relationship. It looks like it's a fairly good relationship. If you want to go over to stats, you can go to stats and you can actually find out what is your R² value. So you can see this is not a very high R² value. It's not too bad, but it's not the highest one. And then we can come back to our data. And if you want to see the graph bigger, you can go click on graph and you can see a little bit better idea of this graphic. You can see that, yes, it does look like there's a bit of a linear relationship going on here. The line helps to see that. And the activity actually has them realizing, okay, this one is, it's a reasonable scatter plot considered linearly. And this one had an R.5. And that's because their R did. Whoops, going wrong place. And that's if I go ahead and change my sample size. I could change my sample size to n equals 100 instead. I can do a new graphic. I can do a new sampling and just keep resampling. And then I can get my different R's based on that. So I can look at these, see these different things that are happening and change these. And so that's what she has you do, is it has you go through and you can look and see, well, income actually has a different relationship altogether. So let's look at what income does for BMI. And what's nice is the students can see not all relationships are positive. This one is actually a negative relationship going on. You can go over here to stats again, find out what your R² value is, and look at what's happening with the data. So it's just a good way to get your students to see what different relationships are going on, play around with the different ones you can see, have a relationship going on, and see how this works in. I'm curious about the sleep hours, so I'm just going to go to sleep hours just because I'm curious what happens with that one. So we're going to go to, again, categorical and sleep hours. And again, you get a nice negative relationship. And you can kind of see, it doesn't look like it's real strong here. Again, we can go look at the R² value, and it's fairly weak. You can also, and she doesn't actually go into this, but you can add in a covariate. So if we go back to BMI and maybe back to income, we could actually add in a covariate, which is just another variable that explains it. We can maybe add in sex. And you can see now we can decide that females and males have a slightly different relationship for their BMI and their income level. So you can see those dots and see what's happening. We can make the graph bigger so you can see all that. And so you can add in those covariates. Yes.
So the red line and is for females and the blue line for males.
Right.
What happens if you get a new sample?
That's a good question. Let's take a new sample. Now it's different. So remember, this actually allows the students to see that every sample gives you slightly different information and you might not get the same thing. And I would keep resampling and see what happens. And as Jennifer showed, you can actually freeze it and then compare, and then keep doing new samples for the other one and see how does it change and compare with that one. So you can actually see that it doesn't look like it's a very strong relationship between that. Female and male might not be a really good indication of your BMI and your income level because they keep changing. And then once they've gone through all these explanations, they then actually ask the students, then it's time for the students to start doing it on their own. They're going to switch the source package to Mosaic and pick different variables to work with. We're going to work with wage as the response variable. Sorry about that. I keep hitting the wrong button. There we go. So we're going to pick on.
Change your
You
data
don't
set.
have the data set.
I don't have the data set. There we go. Okay, wage. Wage.
CPS, I think it is.
CPS, okay. CPS is at the top, isn't it? Yeah, there it is. And then we're gonna go pick wage. And then they have us, again, try different age, different response variables and see what's happening. So we're gonna pick, I believe it was, actually I don't remember what it was. It was age. Okay, so we got wage and age. And again, you can see kind of what's happening. And I would look at that relationship, see what's going on, compare different ones and see. And it seems that as your age increases, your wage increases. And again, you can add in a covariate if you want to. And so it allows the students now to start exploring and see what's happening. It has them set the source package to little apps and pick a different data set and a different one. And they keep working on that. And then they're even going to have more open-ended exploring where they can get more information and just practice trying different things that they want to look at. And they get to pick their own explanatory and response variables at this point. So it's kind of nice for them to play around a little bit and just see what's happening. And then they can fill out information and see what's going on. And this goes on for a while and you don't have to do all of them, but it just gives your students a chance to kind of explore. So
Hey,
yes.
One thing that I like to do with that app is have students search out variables to match a certain value for R or for R squared. So
Right.
Everyone likes puzzles, I guess. Little kids like puzzles, students like puzzles. Find me two variables that you can get close to an R squared value of 1. Can you do it? And then they start thinking about the relationship of the variables, what they actually mean instead of just these names and did they match? Like, oh, BMI and weight, I think they're related, and they'll make those connections.
That's a great idea. I like that. And so as Jennifer's showing, you don't have to use the little activities, the activities that go with the little apps. You can do your own things and just have your students explore a little bit. And that's a really nice feature. So these are the 3 activities we were showing today. As we said, there's 12 of these activities that you can go to and look at this website. So you can go to this website, see those different activities and play around with them. And the main thing is for you to play around a little bit before you give them to your students so you know what's going on. And then your students can play. But these are ready to go activities for you to use in your classes. We don't have the solutions, but you can certainly come up with your own solutions. And the solutions are difficult because they're exploring so much. They don't always have the same data sets they're working with. And so there really aren't, you can give them example solutions, I guess is what I give to my students. All right. So we're at the question time. So Danny,
Yeah,
do
Kate, we have some questions from the chat while you were presenting. And in asking the first one, I'd like to ask you to bring up that the density little app, the one you had that was showing, that you showed in the common and rare.
Okay.
Right. So if you could bring that up, that little app, we have a question about something, and I'll ask it when it's up. You just need to bring up the app.
Yeah, I'm just trying to find the right window that I have up with it. I have too many windows open. And how that goes. There it is. And
Yeah,
if you've been
that's-
sitting for a while, you have to reload it because it's been inactive. My internet seems to be slow. Sorry. There it goes. Okay. So what was the question?
All right, let's look at it. An example histogram or density plot, I guess it is. All right, so the question we were asked is about the z-score. And Kate, you can't know this, but on Zoom, the z-score doesn't show up when you hover the mouse.
Oh,
But it is there at the top of the screen. Right, so if you move your cursor off, you see it says z-score and mouse hover 0. And then it should change. It's not showing up as changing. There it is. Okay, so you have to leave it for a little bit. Here was the question. Is a z-score kosher if the distribution is not normal?
okay.
And what I'd like to do is open it up to the panelists to discuss that just for a couple of minutes. And what would happen if you looked at other data, what you think, is this approximately normal? What other kind of data do you see that's maybe less approximately normal?
I would say it is, with the caveat of knowing the shape of the data set. So the z-score just tells you how many standard deviations from the mean you are. So it wouldn't matter the shape of the data, but if you're going to compare to different data sets, one that's normal, one that's not, you have to understand what it can tell you about the percent of data between two z-scores, which is another step.
Yeah, so I agree with Jennifer. I think z-score is not dependent on being a normal distribution, so z is fine. The percentages, if you're trying to use the empirical rule, that must be using the normal distribution. But you can still talk about what percent are between values by these are actually 31.1% of the data actually falls between these. This is not the empirical rule. This is actually just how much of the data fell between those two bars. And if you're trying to go with an empirical rule, then you'd have to use the normal distribution.
I just
Can
had
you
an
put up
idea.
another variable so we can see maybe something that's less normal?
Yeah, some classes of mine teach Chebyshev, some of them don't. And it is a hard concept for students to understand because they have to put in this value for K and what is it really telling me? And they're working with this extra formula. I think using this app with a variable that's not normal, we could have the students go out a certain number of standard deviations and then compare what percent of data is between these two. And then does it match up with this Chebyshev's rule? So to sort of use empirical data to prove Chebyshev's, or maybe show how it, how close.
One thing that students think is that if you have more data, it becomes more normal. Could we explore that? Just
sort of, if we're talking about sample sizes.
So I have 1,000 data points and that doesn't look any more normal than it did before.
okay.
Yeah. I put up a link. This is sort of backtracking a little bit. I put up a link in the chat, and it is to this visualization that I learned about this summer, perceptions of probability words. So if you do an activity where we're talking about, well, what is common, what is rare, as sort of a side tangent, you could go to this website where they've collected data on assigning a number to a probability word and then seeing how much variation there is just among those words. We don't need to show it up on the screen, but people are welcome to go see that. I just found it really interesting, and I share that with my students, that we define words differently.
So what I like about this is it shows here's our z-scores, and the z-scores are still of importance, but the percentages certainly do not match up anywhere with a normal distribution to percentages. But again, this is 31% of these data values fall in between these two lines. And you can still talk about what that is. This is a z of 0.1, this is a z of negative 0.9. And so you can still talk about the 31% of the data is between those two bars. They're one standard deviation below the mean. It's got 31% of the data.
Kate,
Great.
why do all the points stack up in these nice little bars?
I believe it's because the data I used was income. And I believe this one is actually just putting them as one, like an income group. Is that right, Danny?
Yes, if you look at, there's another variable, income poverty, which gives people's income as a fraction of the poverty. And I think that's more discrete. And then anyone who's above 5 times the poverty level is just recorded as 5. So it's a funny combination. And that's also not normal, right?
Right.
I mean, not a bell-shaped distribution. We had another question, I think is a great question. Do people worry about p-hacking?
I don't worry about p-hacking in my classes because I'm more worried about, I actually care more about, I actually use pretty much confidence intervals these days. So P's don't really get much to me, but it is an issue. And I think I do mention that you shouldn't be doing that in my classes, that you shouldn't be just looking for the best p-value going on. But so I don't worry about it in my classes, but I do mention it so that they know that it could happen.
I don't think I mention it. I probably should. But
Well,
go ahead,
one
Danny.
thing you can do if you're in an app that shows a p-value, like the t-test app or something, you can collect samples until you find a p that's very small.
Right.
And that just shows, sometimes you can find a p that's very small. It comes just by accident.
Right. I was trying to get to the T one. I don't think I'm there yet. So we could show that, but yes, you could do that. But I try to tell my students they shouldn't do that.
And we've had a participant point out that income is hardly a normal variable. I guess we know that from the 1%, right? They're not 3
Right.
standard deviations out. They're $2 billion out.
Right.
Other questions for people to speak up, please unmute yourself and speak up. Or maybe, I don't know if you can unmute
Yeah,
yourself.
I don't know if they can unmute themselves.
So if you have a question, type it into the chat. There's a little cartoon bubble at the bottom of the screen that lets you bring up the chat. Well, Jennifer, I have a question. What's been your students' reaction to these activities?
I actually ask them that when they turn in their work. I have them answer questions and they put them into a discussion so that they can see everyone else's answers, especially when they feel like they're struggling and then they read someone else's work and see, oh, they're struggling too, I'm not alone. And then I ask, what were your big aha moments? And so for the regression app, I get a lot of responses of, oh, wow, I could pick the variables. These two variables made sense and they made a high R squared, where if I randomly pick 2 variables, then R squared isn't very high. And with the support of the video and then the leading questions, they can get to a better understanding of the linear relationship quickly. So I get good feedback from them that they like it. And
Great.
yeah.
Well, we're coming to the end of our time, so I'd like to thank our speakers, Kate Kozak and Jennifer Ward. And I'd also like to acknowledge the other instructors who've written these apps. And I think that it's a potentially very valuable resource for instructors nationwide to be able to quickly come across an interesting activity or demonstration for their class. So any final words from you, Jennifer, or you, Kate?
The only thing I'd ask is if Kiera could put in the survey link in the chat for the survey of the webinar, that'd be great.
Oh, yes. And so we're going to post that link. And we do ask that you do the survey. It's one of the ways that the National Science Foundation estimates whether a project is doing anything for the community that it's targeted to. So whatever you have to say, positive, negative, please say it. That'll
Yes.
help us make things better. Thank you very much.
Thank you.
So, Kiera, is that going to come to them right afterwards, or is it in the chat?
Usually it goes directly after they end, and then it will be directly sent to them.
Okay, perfect.
And then I believe this recording will be up on our website in the next week or so.
Yes.
Yeah, usually within the week it gets posted.
Oh,
be
and
posted.
the things I forget. And next month, our plan for the StatPREP webinar is to have a conversation about data science, because all sorts of deans seem to be interested in having a data science course or a data science program. And we want to talk about what a faculty member might be able to do in that direction. So that's going to be next month. The date isn't scheduled yet, but it will be on the statprep.org website. Again, thanks, and have a good week and weekend.
Bye, y'all.
Bye all.